What's up, everybody? Tim here. In the last video that I uploaded, I showed you an application that hid messages inside of some lorem ipsum text using a book cipher. In this video, I will show you one of the components that went into the making of that. So as a recap, if you don't know what a book cipher is, you can learn more on Wikipedia here, but the very, very quick version is that the idea is if you have a message you want to send to someone, you agree upon a book ahead of time, some string of text, so like a literal book, or in the case of what we'll be looking at, just a string of text. You know, whatever message you want to send, you would go and find some reference to the words or the letters that you want to send inside the book. So if you chose, you know, The World or Worlds as the novel, as a book, you would, and you wanted to send the message, you know, hello world or something like that, you would go in the book, you would find a page that has the word hello on it. You would write down, you know, maybe the page number and then the index of the word on that page or something like that, right? And then you would go and find another page that has the word world on it. You would write down the page number and the index of that word on the page, and you would send those numbers to the person who you want to send the message to. You would have agreed ahead of time on that book, and so they would know to decode the message. They just need to go and find the page numbers and then count out the words based on the numbers that you sent them. So that's the really quick version of how book ciphers work, and what I'm going to show you today is a Python implementation of a book cipher. So if you find this interesting and you want to play with the code, you can find it on GitHub here at github.com/foamyguy/Python book cipher. And I will, in this video, I'll show you kind of a quick look at what is in that repo and how you can use it to make your own book ciphers. And then in a future video, I will dive a bit deeper on the actual book cipher class itself and how everything inside of it works. But today, we will focus just on how you can use it to make your own book ciphers, similar to the lorem ipsum one in the previous video. So with that introduction out of the way, I will jump in, and you can see we are here in the book cipher class, which is the key to being able to create your own book cipher using this project. So what I will actually show you, rather than just stepping through all the code of the book cipher again, I'm going to show you just the bits you need to understand really to be able to use it. So the main thing that you need to do if you want to create your own book cipher using this superclass is basically just create your own class and extend book cipher. So here we have an alphabet book cipher. We extend book cipher. We have the init function. We can take any special parameters that we want that are specific to our special kind of book cipher. So in this case, it's an alphabet book cipher, and it takes an argument that is an alphabet count. We'll get to what that does here in a little bit, but beyond that, we just call super init. We set the alphabet count onto a variable on self so that we can access it later. And then now that we have extended book cipher, the only other thing we need to do in order to actually get our book cipher working is just implement a property that is called bookstring, book_str, and you need to make that property return any string that you want. And the string that gets returned from this is essentially going to be the book that we are going to use for our book cipher. So this alphabet book cipher, I think is a good example of how the class works and how book ciphers in general work. So I'll show you this one first. And if we just run it as is, what we can see is we are encoding the message hello world, and we are encoding it inside of just an alphabet. In fact, if we wanted to, we could go ahead and print out the book string. And so we could even see the full alphabet in this case. So we have, in this case, actually a lowercase alphabet and an uppercase alphabet kind of smashed together there. And so hello world here, it's not very complex the way this encoding is working. You know, H, E, those are just the numbers of each letter in the alphabet. H, E, this is a capital H, so it's way over here at the end. E, is the index 4 of the alphabet, right? The fifth character. If we zero, if we count on starting at 0, then it's the fourth index, the index number 4. So on and so forth. We have two L's, O, we have a space, WORL, we have another L there, which we can see is 11, D, and that's our hello world. And one of the interesting things that this alphabet book cipher is going to allow us to see is the way that this code, the parent class, the superclass, will actually try to help make it a little bit trickier than this, right? Because if someone were to intercept this message, it's actually, in this case, it's really, really, really easy to decode, because it just maps up to the alphabet. But even if this didn't just map up to the alphabet, if we imagine it mapping to some other numbers, we still have this repetition thing going on where, like, if every L in the entire message always maps to the same number, or every E always maps to the same number, that's going to make your message easier to decode with just frequency analysis on those characters. So I'll up the alphabet count to 2. We'll rerun this, and what we can see here is we end up with the full alphabet, the full uppercase. There is a space, and then there's another full lowercase, another full uppercase. There's actually a space here at the end as well, which we can't see visually. And so this time, what we see is we actually end up with different numbers here. So the numbers are the output of our book cipher. I should show you the code here that's doing that. So we create the book cipher. In this case, we're telling it how many alphabet count we want. We added this line to print out the book string. We say that our ciphertext is going to be equal to our object, our alphabet book cipher instance that we created there. We call encrypt. We pass the plain text message that we want to encrypt. We're going to get back that list of numbers right there. So that just gets printed out. When our friend on the other end of this message receives our numbers, they can come and instantiate the same alphabet book cipher, and they can call decrypt. They can pass in that list of numbers. They're going to get back the clear text. Okay, and so what we can see when we have alphabet count on 2 now is that the L's are actually different. So we have LL. One of them was 11, just like before, but the other one is actually 64. We do have a third L here, and we can see it does eventually repeat. We do have another 64 right there. But we can see we got a little bit better. Not all the L's are the same. That's a step in the right direction. And in fact, if we were to add a third alphabet to our alphabet count, you can see there now our book has 3 alphabets in it, and we have HELL. We have the 11 again, but we now have also a 117. We have our 64 here. So now we have 3 different L's in our hello world message, and it will do this for every letter. So it will attempt to use indexes that have not already been used. It will eventually have to reuse them, like if we just try to encode several E's, obviously we only have 3 E's in this particular book string, 3 lowercase E's, I should say. So we use all 3 of them, and then we have to repeat, one of them at least in order to make 4 E's there, right? So it will try not to repeat, but it ultimately depends on your book. You are kind of stuck with however many characters are in your book. So if you wanted to use this mechanism, you would want to choose a book that has a lot of characters inside of it. The alphabet one would not be a good one. This is mostly just good for showing how you can create a very basic version of a book cipher and how the repetition, it will try to help you with it by not repeating when it can. So the next one I'll show you is a little bit more of a practical one, and this is the only other one I want to show you today. So we will wrap it up on the video after this one. The textbook cipher. This one, again, extends book cipher. In the init function, we have, it takes a text file. We have super init. We set text file onto text file self so that we can access it later. And then again, we override, we implement the book string property, because that's what we have to do. We extend book cipher, and then we implement the book string property. Those are the 2 things we have to do to make our very own book cipher using whatever, quote unquote book we want. In this case, it's going to basically expect a file path to a text file. is going to open the text file, and then the book is going to be all of the content inside of the text file. And in this example code here, I've used testbook, and what I have inside testbook is actually a book from Project Gutenberg. So for anybody that doesn't know Project Gutenberg, I should have opened this in the browser. I didn't. Let me pull it up. Project Gutenberg. So for anybody who doesn't know, Project Gutenberg has a bunch of free books from the public domain. You can kind of click into any book that you want here. You can go to plain text right here, plain text, and that is literally just a text file that contains the entire book. So for the test book that I've used here, I literally just got one of these and copied it, and you can put it here. It's got the header that tells you the license for what you're allowed to use it for, and then it's got the book just right after that. Just gets right into it. So I used the Frankenstein ebook, but you can obviously use any book that you want. And if you want to get a good source of free books, check out Project Gutenberg. But certainly, you could use different books as well if you can get them into text format, or if you can create your own subclass of this to read from a PDF or an ebook or whatever you want ultimately. Okay, so textbook cipher, back to this one. It's going to read it out of the text. That's going to be our book string. And so the example here opens up testbook. It says encrypt the super secret message and then print the ciphertext, and then it will go ahead and decrypt the ciphertext as well, so that we can see that it's going to get converted back to the proper clear text. So let's run this one. Run that right there. It does take it an extra second. If you could see there, it kind of paused for a second because this is a lot of text to just read into memory. We're not doing any fancy efficiency stuff or anything. We're just opening that text file and reading it, and that thing is well, I don't know how big it is, but probably hundreds of kilobytes, which is not huge, but it is a lot for just one string to dump into memory. So it takes it a second, but once it does, it then spits out the ciphertext, which again is just a list of numbers. So these numbers correspond to indexes within the book. So my book, again, is Frankenstein, but you can use whatever book you want. These numbers correspond to indexes within the book for each letter. So if you were to grab the same copy of Frankenstein that I got here from Project Gutenberg, and you were to go find the character that is at this index, 59,044, it would be a capital S. And if you were to go to find one here, it'd be U and then P and so on and so forth. So all of those are inside the book at these indexes. And again, because we have a very full book with lots and lots and lots and lots of characters, we don't really have to worry about the reuse at all, especially with a really small message. We do have some repeated S's here, but there are almost certainly more than 3 lowercase s's in this entire novel, and the header as well counts for this book cipher thing. So there are certainly more than 3 lowercase s's, and so there will be no repeats here, which is pretty cool. All right, so that's the book cipher. Again, if you want the code, github.com/foamyguy/Python book cipher. If you want to learn more about the actual innards of the book cipher class, then stay tuned. I will probably post that video next, but it might be another couple of weeks until then. If you would like to encourage me to do that, one of the ways you can do that is like this video, leave a comment letting me know that you found it interesting and you want to see the insides of the book cipher, if you do, and that may help it come along a bit quicker. But with that, I will bid you farewell. I will say thanks for watching. I hope you have a good day, and see you later.